All right, so I'm going to rewrite the title. This is 1.1 Patterns in Inductive Reasoning. So, jumping into these problems, the first group of problems gives you some like pictures and some visuals of things. And so, basically the first one, number 14, gives us a box that has essentially another box or like diamond in it. I'm gonna see if I can like okay. All right, so I know you can't just like copy and paste on your paper, but this is essentially what you're looking for. If you want to just look at it in your book, it's on page 6. But what I'm going to do is they each have lines in them. So this first one has a line here and down, or well, a line down here. This part up here is colored in on this one. The next one, it's over here, and this side has 2 lines. This side over here is colored in. And then this one has 3 lines up here. And this part down here is going to get colored in. Oh, I skipped one. Oops. Back it up. 1, 2. There we go. So now what I'm doing is I want to find out what this 4th box should look like. Any guesses? Just say it.
4 lines on the right side, and one colored line on the left side.
Yep, so 4 lines on this side over here, and then 1 colored in over here. And I'm not doing a very good job of drawing them, but in theory, as far out as these lines go, that's how much of this side should be colored in, but I'm not perfect, so. So on these ones that are like you're drawing something, if you don't want to copy them all down because some of them get a little crazy, you don't necessarily need to like copy every single picture down. But on normal problems, whatever the problem statement is, you need to like write it down. All right, so that one was one with a picture. So now we're going to do some that are basically a sequence of numbers, and we're going to be predicting the next number. And they want us to describe what's happening of how we get from one to the next. So like the one where we were multiplying by 4, we would say multiply by 4, and then we would say what the answer was. So in that case, it was 256. So that's what we would put. So 16, 1, 4, 7, 10. So 13 would be the next number. And what are we doing to get from one number to the next?
Plus 3.
Yep, add 3. And that's all you have to write on those ones. All right, 18. We have 1, 11, 121, 1,331. Yep, we're multiplying by 11. Does anybody know what the next number is?
Give me a second.
I can just tell you. It's 14,641. And this is actually an interesting pattern that will make more sense next year when you take Algebra 2. But That's part of Algebra 2, but this is actually a part of Pascal's triangle, the pattern of the numbers that it's making. But anyways, you don't need to worry about that right now. 20, 7, 9, 13, 19, 27.
It's like plus 2, and then plus 4, and then plus 6, and then plus 8.
So plus 2 every single
Plus 2
time.
every, plus 2 more onto the addition every single time.
So we're adding consecutive multiples of 2 every time. So what's the next number? Yep, 37. Because this one was up to 8, so then the next one would be 10, so add 10 to 27. Yes.
So do you only do even numbers, or supposed to only do the odd numbers in the problems when we do our homework?
I'll assign you problems at the end. But yes, typically you'll only have odd ones unless there's like a really good even one, and occasionally I do an odd one if I feel like we need to do something else. Because sometimes the problems are like paired up, so like say 19 and 20 will be similar, so like we'll be good, but sometimes all the odd ones will be like one type of problem and then all the even ones will be different, so sometimes I have to do some of like both. But for the most part, yes, that is what will happen. Let's see. Last one of these ones is 22. We've got 256, 16, 4, and 2.
0.5.
Do what?
Is it 0.5?
No. It's probably may not be as easy to see going from 256 to 16, but how do I get from 16 to 4?
By multiplying by 4. Oh, yeah.
Okay, dividing by 4. How do I get from 4 to 2?
Divided by 2. Oh, so you
So it's not technically divide. I mean, I guess it is dividing, but is there another way that you can see how I get from one to the next? How about a square root? Because the square root of 256 is what? 16. Square root of 16 is? Square root of 4 is? So then what would the next number be?
would not be 1.
Right, which is why if you say dividing, you probably end up getting it wrong.
Is it gonna be a negative?
It's a decimal of 1.
0.2.
Why would it be?
So how would I find the next number? Take what?
Take 2 square root.
Take this, yep, square root of 2, so we just write it as the square root of 2, which is like 1.41, but you would just write it as the square root of 2, and then we would just say take the square root of the next number. That's how we find them. Questions on those? All right, back to a visual one this time. 24. So they give us, these are like actually cubes, but I'm not going to write them. I'm not going to draw them as cubes. Whoa, that one's crooked. So the first picture I have 1. The next one I have 3 on the bottom, and then 1 on the top. And the next one I have 5 on the bottom, and then 3 on the middle, and 1 on the top. And they want to know what the next picture would have in it.
7 on the bottom, 5 in the middle, 3 in the upper middle, and 1 on the top.
Yep, so 7 on the bottom. And then basically it takes what you had before and just stacks it on top of that. So then 5, then 3, then 1. So that would be my next picture. So again, on the ones that have pictures, we can just do that. Now, they actually specifically ask us the question of how many blocks are in the next picture. So how many blocks total are in here?
16.
Yep, so 16 blocks would be what they're actually asking us for. Which technically you could figure out without having to draw it, but. Okay, so the next, well, 3 problems go together. We're doing the even ones. You'll have the odd one to do as part of your homework. But they say to use the pattern from example 1. So if the very first like example that I had put up there, where you were like it was the little like blocks that looked like Tetris pieces. So they've given us. So this is for 26 and 28. Basically, we have 1 block. Here, I've got one that looks kind of like an L. Then I've got 3 on the bottom, then 2, then 1. I've got 4 on the bottom. And then 1 more, 5 on the bottom. Too many. So this is figure 1, 2, 3, 4, and 5. So question 26 specifically says to find the distance around each figure, and what we're told is that each square is basically 1 by 1. So this is like 1, it doesn't have like specific units, but 1 unit by 1 unit all the way around. So I'm trying to find out how many basically units around each one is. So they say to use a table for it, which is honestly the easiest way to do this. So I'm going to set up a table here with the figure number so I can keep track of which one I'm dealing with, and then the distance for each one. So I'm going to go 1, 2, 3, 4, 5. So the distance around this first one, there's 4 sides, so it's 4. The distance around this one is, if I start down here, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. This next one is, well, 3 on each side, so that's 6, 7, 8, 9, 10, 11, 12. So that one's 12. And so on and so forth. This one ends up being, I'm not going to like manually count it out, but 16. And then this one
20.
is, 20. So this would be your answer to 26. Okay. Question 28 then asks for predict the distance around the 20th figure. So I don't really want to draw out the 20th figure because that kind of seems like a lot to draw considering you have 20 blocks on the bottom, 20 going up the side. So let me see, can I find a pattern here for how to get there?
You're doing 4, you're adding 4 each time, so you could kind of just do 4 times 20.
Yep, that's exactly right. Yep, so we would do 4 times 20, and that would give us 80. So that would be our answer to that one. Any questions on those so far? All right, 30 These ones say to complete the conjecture based on the pattern you observe in this specific case. So the conjecture is the product of any two odd numbers is, and then they give us a blank. And so they give us some examples here. They say that 1 times 1 is 1, 1 times 3 is 3, 3 times 5 is 15. I'm not going to write them all out. 201 times 305 is 61,305. So the product of any two odd numbers is what? Odd. And that's your answer for that one. Now, you don't have to write out all of these little things when you do it, but you need to write out the problem statement when you're doing your work. All right, the next ones say find the counterexample. So show the conjecture is false by finding a counterexample. 34. All prime numbers are odd. Is that true?
No.
What would a counterexample be?
2.
Yep. 2 is prime, but not odd. Or you could say it's even. Typically they say like not whatever we're trying to find instead of just saying what it actually is. But if you were to say 2 is prime because it's even, or but it's even or something like that, that would also be fine. 36. The product of two numbers don't put that gum in your mouth or it's going to become mine. The product of two numbers is even, or if the product of two numbers is even, then the two numbers must be even. Is this true?
No, it's not.
Can you think of an example?
1 plus 3 is 4.
This is multiplying.
Multiply.
So basically find an even number and then tell me how you multiply to get to it. How about 12? What do you multiply to get 12?
2 and 6.
Okay, those are both even. What'd you say?
3 and 4.
Yep, 3 times 4 is equal to 12, but 3 is not even. Let's see. Last one. The bell might ring, but don't leave until I give you your homework problems. 38. The square root of a number x is always less than x. So I'm going to quickly give this to you. Do not leave. You need to write down your homework problems. So this would be if I had like the square root of 1/4, it's equal to 1/2. This is similar to the one that we looked at a little bit ago. And 1/2 is greater than 1/4. All right, problems are, and normally you will have some time in class just because we had to go over the other thing at the beginning. That's why we don't have time today. 17, 19, 21, 25, 27, 29, 31, 35, 37, 39, 47, and then a couple review problems, 63, 65, and 67 tomorrow.